Hi all. Today I wanted to quickly take you through all the source code that is run on the server, and I wanted to quickly show you what that looks like. So here we have Visual Studio, which is what I use to write CremaBot in. I think the software should be completely compatible to Visual Studio Express if you want to try this at home. I don't think I used any of the enterprise type features. Okay, so let's dive into it. So you'll see the project is divided into these four different projects. Sorry, the solution is divided into these four projects. So that's the website. Then I have communication, which contains the actual serial, which contains the communication via the USB port to CremaBot. Then I have a little test command shell application, and then there is the same functionality exposed as a web service. We're not going to go through the web service today because it is really fairly simple, but I wanted to quickly take you through the website. So here we have the website. It's a stock standard MVC 4, I think. MVC 4 template. You'll see there I've got standard views, the home view, which contains the index, which is where all the action happens, and I've just added a context, or I've left the context and the abouts page, which I'll take you through in a moment. The Signal R implementation is here in the hubs section. There's our message hub. Right, we have the standard controllers, a home controller which has a bit of code. And then the other stuff that might be interesting is the dot metric sprite. There you can see that it's let me get it go away. Oh, no. That's effectively the entire sprite, right? So I've pretty much just drawn a transparent background, couple of dots, couple of layers. I actually used paint.net to do that with. I'll add a link down below if you wanted to have a look at that software. It's free graphic software that I kind of like, and it works quite well. But then you've got all the characters, all the numbers, a space, and then the open block and the close block, similar to what you get on the actual machine. Next up, we'll look at the rest. Is pretty standard. This is just a photo of the Gineer machine that I overlay. So you'll see that in that machine the images in the top are blanked out. So I just overlay the dot metrics display over that. I don't even think I didn't make use of any models because nothing is stored in a database at all. Some scripts, etc. So let's get going. Oh, one last thing I wanted to quickly show you is web config. Again, stock standard. The only things I've added is that, and this then provides the COM port that CremaBot is talking over, and the baud rate that it connects at. What you'll see in this version is I've actually made authentication none. In the initial version, I actually set that to Windows authentication, which allowed people to log on to the site initially before they make coffee. And all, the idea was that you log on once, you get authenticated, and we can actually just, out of interest, see who makes use of the site. Since this is a work setting and we're on a domain. But it seems our half-eaten fruit mobile phones had difficulty saving the password, so it became a bit tedious. They had to retype the password every time, so I changed that, set it to no authentication, so it's fully anonymous at the moment. That's the config file, right? The next thing, let's quickly go through index. So this is our home page. And you'll see what this, as you can see, this is stock standard MVC, no frills, no fuss. And there's our display character. So you'll see there I bring that dot metrics sprite I showed you earlier in as a background image. And I set the specific position in the background. And there's just a couple of standard stuff. There's a little action button and so these are the little buttons on the coffee machine that you can press, and I do those down below. So what else have we got? So here's our actual action buttons. You'll see there's the same class as we have up above, and I just position it correctly. So I do the top positioning there, and then I position each button just to overlay a square over the buttons on the thing, so that I can capture the click event in jQuery down below. Further on, I just set a couple of default characters. I just get them lined up nicely. So this is setting the sprite. This is setting the sprite in the background, so each of them sits in the right place. And I then, so there I just load jQuery in, I load SignalR in, SignalR hubs, and yeah, off we go. So what happens is, effectively, we sit and listen for the message hub to send us a message. As soon as I get a message from the message hub, I check whether we are busy with a previous message, and if not, we set that state to true, and I disable the buttons on the keyboard. So when someone is busy making a coffee, no one else can make a coffee. I clear the display, and I send them incoming message to be displayed. If one of those messages starts with error, HWV, or rinse, I follow a different path, which I'll show you in a bit. So error, I've got some error messages coded in if there's a problem with a serial connection. If the USB cable is unplugged, I'll show you that. On first startup, I just show the hardware version directly from CremaBot, just to be sure that comms are up and everything's fine. But under normal circumstances, we set this to false, and we then set a counter and I display the message. If it's not any of these. So if there is not an error, if the message doesn't start with any of those, we wait 14 seconds, and we kick off to a project called to a method called show progress, and we pass in message. And also other circumstances, we just display this error message, and we stop working, and we end. Right. So there's some. Now we just do some variables. There's a counter we set to 0 and the default message. On our character map, this actually exclamations equate to the open square you saw on the sprite earlier. So here's our show message. So we display message, the progress message, because now obviously we've displayed the text, then we show the progress message. And I'll take you through, so this is the prog message, just all open squares. And we replace where the counter is at this stage 0, the first one, now backslash equates to the closed square, right? And we just go through and we start looping. So what this thing does is, after every 2.3 seconds, it replaces another one of the open squares with a closed square, and that's how we get our progress display showing up. If the counter passes then beyond the 10 squares that we want to show initially, we clear the display, we show the original message again, and after 9 seconds we come back, and at that stage we just set the variable back to where it was, we clear the display, and we say ready for the next button press. We open up all the buttons again, make them accessible, and we set working to false. Okay. Here's just a little subroutine I created. Display message, this is where all the magic happens, turning the content of the message into those sprite images you saw. So I'm not going to go through too much detail, but effectively we divide the length of the sprite by the character code, etc. So there we get bytecode. If it's between 65 and 91, it means that we're in that part of the sprite. If it's between 48 and 57, so I think these are the numbers, we're in that part of the sprite, and these are the last two characters, 2 or 3 characters including the space. And then we just set the appropriate background or position data on the sprite, and we get our dot matrix display. Here's our buttons click methods. So what I've said, when you do a rinse, this really only happens once, and you should be in front of the machine because generally you don't want the thing to rinse into the water tray in the bottom. It keeps things nice and neat if you have a cup under there. So I've said, if you really should be in front of the machine to use this function. So when you click it when you click this button on the machine, it works fine. If you click it on the website, it just warns you that you should really be there. When we move on, so all these other buttons, so this is our espresso key, 2 espresso, 1 coffee, 2 coffees, and the steam key. You'll see I've also set the steam key to not actually send anything through, but the rest of them, you'll see on the message server, they send the command corresponding to the button they've pressed, and I'll go through that in a bit. And that's the end of it. That's all of index. So what we end up doing with these guys, if we have a look at our message hub, okay, so here's our message hub, standard setup. All I do at the beginning here is I actually instantiate the serial DLL or object, and you'll see that I've got serial instance happening. So what that means is that serial itself is actually a singleton, and I'll take you through that in a bit. And I set up the events, and I get it to connect to CremaBot. There's a send command. All it does is serial send data, and it pushes through that message. So the character we saw right in the beginning gets pushed straight through to CremaBot, and off it goes. It then also forwards any messages received from CremaBot. So you'll see that in a bit. It forwards all of that. I can't remember where this fits in. Actually, I've been looked at this code for a bit. But effectively, this pushes that message through to all the various hubs listening, or nodes listening from the hub. Here's our data received message. So the data could be either exactly the same, a lowercase c, capital C, etc. Distinguishing those various messages, and there we go. I use send message, which is this guy up here, which then just forwards it out to all the nodes listening to the hub. Here again is all the hardware and the error handling messages that happen there. And I mean that's about it for the MVC bit. Very quick and easy. I do have an about and a controller page. Sorry, an about and an context page, just for a bit of fun. So let me show you that quickly. We might end up with an exception because it's actually trying to connect to CremaBot, and the hardware is actually not with me. It's installed at the client. So what we have is our website popping up, right? So and there's our interface, right? So there's our buttons. Okay, there's our interface. There's our buttons. If I press this guy, I get the message. So that's a bit ugly at the moment. I'd like to actually redo that and just make it a bit cleaner, make it a nice kind of overlay message or something. But yeah, there's our buttons. You can click any of them and it'll actually make the machine work. There's our dot matrix display. And then, as I said, there are a couple of other pages. Pretty straightforward. All I've done here there. This is the CremaBot playlist. Okay, that's it for the website. Let's have a quick look at our serial object. So here's our in communication serial. So all I've done here is I've set up the event handler. There's a serial class. This is all fairly stock standard, but I thought quite interesting anyway. So there we just initiate our serial port name, baud rate. There's our constructor. So you'll see that our constructor is a private constructor. That's obviously consistent with the singleton pattern. So we read the config, just get these variables up the top. We set up a new port and our event handlers. So here we have our public static serial instance. So this is obviously where you set up the singleton stuff. Our get method checks if an instance exists. If not, it locks. Checks that the instance is null. If it is null, we create one. If one exists already, we simply return that instance back to the calling program. So there will only ever be one instance of the serial object running at any given time. Private methods. As a read config, as you saw earlier, we simply get from the config file, which is sitting in our website under normal circumstances. We get the baud rate and the port name out of there. As a data receive event handler, right? So all that does is invoke the standard event handlers up the top. Here we get that information again. We simply trim off any, because CremaBot returns with a new line and a carriage return, or carriage return and a new line character in the back. So I just trim those off, just an easy way to do that. I just build up the data model. I simply put the length in there and I invoke the event handler method. Sending data is quite easy. Any string that comes in, we simply send straight out. And this is where I do that event error handling. So if that does fail, for some reason the USB cable became or disconnected, I just send through an error message. Similar with our connect command, stock standard port.open. Given the above configuration, if that fails, I just send through a connection error. And yeah, it's just some housekeeping. Boolean, I can check, use a command extending to check if it is connected, and it returns it. And over here I can say, this is more of our event handler, data received event. Oh, sorry, this is our event args, our class that deals with or this is the object that passes through our event args for that event handler. And you'll see all I've got is the string and the length coming through. And that's it. I mean, that's CremaBot top to bottom. I don't think it's very complicated, quite straightforward. And if you guys like this video and the series and you've seen the whole playlist, I'd love to hear from you guys and hear what you think. Constructive criticism, always welcome. Yeah, and give it a thumbs up if you like it. And yeah, feedback, please, guys. YouTube comments is probably the easiest way for me to comment, but any other feedback is also welcome. Cheers.